It is not fair that I'm telling you there's a problem if I'm not telling you the solution, right? Because anyone can tell there's a problem and this is wrong, but what's important is, can we give a solution? Today, I'm going to give a solution to the problem I explained in last video. But there's a problem because I'm recording few videos in row, so I'm not sure what was the question you asked for the last video and how popular it was. Anyway, I'm going to explain you the solution I explained in the previous video. The problem was the HTTP based backend are very bad idea for microservice based project. In other words, we cannot get real throughput using HTTP based backend. So today we are going to solve that problem and discuss a solution. This video may go for another one video because I need to explain this solution and motivation and strategies behind this solution, and then I'm going to show you the implementation. This implementation along may take like 30 minutes plus because I need to implement few microservices, Kafkas, brokers and so many things to do. So therefore I'm going to keep that for one more video. But you must watch this video if you want to understand the implementation. Right? This is like a chain. You won't understand this video if you didn't watch the previous video. So go ahead and watch the previous video first and then come back to this video, and then we are going to watch the real implementation. Right? It will be a chain. Second, YouTube telling me I am not reminding you to subscribe to my channel because I forget it. I'm more focusing on the content, so I forget it to ask you to subscribe. But YouTube saying as a strategy, I should remind you to subscribe, like and comment. So before I forget, I'm telling you, if you like to these videos, if you want to help me to create more and more videos like that, then you need to subscribe to this channel, and also you need to share this channel with your friends, because when I get more subscribers, more comments, more like, more feedback, it encourages me to do more and more videos. Hope you will help me as a return to what I'm giving by subscribing, sharing this channel and making this channel to grow up and helping YouTube to get this channel to more people. Okay, right, so let's discuss the problem what we had. Okay, so I'll summarize it. We were trying to implement a solution for mobile company. That mobile company having a multiple service to call when they have a new connection. But this some services may be offline, some services may be not available, and some services may be slow. And in that case, we were in a problem. So now we are going to solve this problem. For that, I'm going to use a design pattern, microservice pattern called SAGA. Okay, I'm going to use a microservice pattern called SAGA. This SAGA pattern we can implement in a multiple different ways. Okay, and also the problem we discussed, the distributed transaction, some database have a record and some database don't have record. We can use the SAGA to solve that problem as well. But today I'm going to show you the SAGA to solve this problem. Okay, SAGA is a well-known microservice implementation pattern. A lot of people using this, but some people misusing it. But always when you have an architecture or design pattern, you always can customize it as long as you know the repercussion, as long as you can deal with the repercussions. Okay, so SAGA can implement in two different ways. Okay, so first one is, I need to tell the first one before the second one, right? Choreographic, right? So first one is a choreographic. The second one is orchestration. Okay, first one is a choreography, second one is a orchestration. In other words, choreography means event based, right? The orchestration means command based, right? I will explain these two and I will explain how we can get this into our solution. Okay, as I said before, I'm recording few videos in row. So if you ask some question about this or like suggest to some SAGA pattern on my last video, still I don't see that because still that video was published technically. Okay, but anyway, so now the choreography and the orchestration we both can use in different use cases, right? But also each one has its own problems. That's what we need to understand. none of this perfect, each one has its own problem, and we are going to discuss that as well, right? So let's try to implement the SAGA in a choreographic way, right? So remember, choreography means we are depend on the events, okay? So let's draw our service. Every time if I use a different color pen, that is a message broker topic, okay? Our solution may be some services in a Java, some services may be in a .NET or something else, or some may be in SJS, some may be Node.js, some may be serverless, doesn't matter, okay? Doesn't matter, because it's a real microservice. Because when you come to a microservice project, it's not necessarily every service implementing in the same language, right? It's always you have a freedom, each service implement different language, because connectivity happen in either HTTP or either this type of a message brokering system. Okay, so now let's draw our structure first, then we can see how to integrate those. So here we have the connection service, okay, which is called new connection service, okay, new connection service. And when the new connection request comes, we need to validate this. I will limit this to 2 services because in order to make this easy, right? So we need to see whether this customer has a good reputation with the fixed line, and if this customer has a good services with the let's say TV connection, okay, whether this service has a good connection, good reputation with the fixed line and the TV, okay. And still I'm not drawing the how this connecting each other, right? If everything is success, I'm not going to have these third-party vendors and all those mobile and all those others verification. Let's say you can have a 10 even here, doesn't matter. Now, if everything is success, this one inform to finance service, hey, you can bill the card, right? This is a finance service or a billing service or whatever. You can say, hey, go ahead and bill the connection fee from this user because this verification is success. In case verification fail, we don't bill from the customer, okay? If the billing is success, then it inform to new connection or operation service, right? Operation service to start the connectivity, right? Establish the connectivity, right? So now everything is good. We verify, we pay the bill and activate the connection. Okay, there can be a bunch of other services, but because if I introduce more services, I need to implement those services on the demo project, right? So I'm trying to limit. So we are going to have Kafka as our event source, event broker here, right? So how we are going to do is, so I'm not going to draw a single Kafka broker here and like draw arrows here and there. Instead of that, I am going to draw a topic with next to the service, so then you can easily understand. I'm going to use a different color. When the new connection come, right? You can see this one, right? Yeah. So when a new connection come, this is the new connection topic, right? New connection topic. So what it does is, so this service publish the message to event to the new topic, say new connection topic, hey, we got a new connection. Now these two fellows are listening to this topic, right? So that means parallelly they get this message, right? So if you publish the message, same time both of them getting the message because they are in a different consumer groups, okay? So maybe he's in a fixed line consumer group, this is in a different consumer group. As a result, they both get the same kind of message. Now he's checking whether this customer has a good reputation with the fixed line, and he's checking whether good reputation with the TV. So if they both success, right, doesn't matter both or not. So you are going to they have a separate other topic saying verification response. Okay, verification response. So now they're going to publish the response to this topic. Okay, they're going to publish the response to this topic. All these are events. No one is waiting. He published the event. and then they consume it, they publish it, no one is waiting. Okay. Now, this new connection is listening to this topic, right? So this arrow side may be a little confusing, but just think that he is listening. Now he says, okay, all verification done. Now he published the message to the new connection topic. You can use the either new connection topic or you can use a different topic. It's completely dependent on your architecture. Okay. So what I'm explaining here, we use the same topic because this is a new connection topic, but the event type is different, right? In this case, event type may be, I'm targeting to the stages, let's say verify stage, right? So the other people who is in this connection, don't bother about that, right? Verify pending, let's say something like that, verify pending. Okay, so now I am publishing the second message to the customer saying verify success. Okay, so understand this, don't get confused. It's completely okay if you use a different topic for publish the verify success message, because these people don't bother about the verification success, right? Because they also getting the message. That's a disadvantage. No matter what you publish here, everyone who's listening get the message. If you want to reduce this network traffic, if you want to reduce this, because let's say this is a lambda, then he will wake up and, hey, I got a message, but yeah, no, it's not mine. Something like that, right? So then it will cost for you because it's waking up, right? So that's why I'm saying it's completely dependent on your architecture. But if you're running on the EKS or ECS or something like that, then it's not a big problem, okay? Because service is anywhere running. But in that case, you can use a separate topic. But easy of explaining, I'm using here. I'm going to say event stage is a verify success, right? So now verify pending. So this guy is listening to the same topic. Okay, this guy is listening to the same topic. So now, when the first message goes as a verify pending, he don't bother about it. But he get the message, okay? Understand that he get the message, but he don't bother about it, right? But these people will act. So now when I send the verify success message, they don't bother about it, but he will react it, okay? So therefore, remember what I said. If they are lambda, or something like you have to pay based on how many times they execute, then this is a bad idea. Okay, this is a bad idea. Why? Because you have to pay for something they don't use. But if it's a service you're running on the Docker or Kubernetes or something, this is not a problem. But still you have a network traffic. Okay, if you're passing millions and millions of messages per hour, then you have to pay for the bandwidth, right? Then again a disadvantage. So in that case, it's perfectly fine. You use multiple topics. So now finance service is done the job, right? It used the credit card and got the payment done, right? So now finance can publish the payment success message, right? The payment success message. So here also you can do the same thing. You can use this topic as a common topic, as a response topic, right? So like let's say then you publish NC response topic, okay? So now you publish the response back to here. So now the event state is a response, payment success. Now he knows, right? This is they response as a verification success. He responds as a, he or she. Don't ask me, I don't know. I'm just saying he, okay? So I mean. So don't question me. How do you think this is like something like insulting for us? Why you think microservice is a male? Why it's not cannot be a female? Doesn't matter. Okay. So now he responds as a finance success or payment success. Now they get the message payment success, right? Again they publish the state saying payment success. Okay, again you can use a different topic, I'm not going to go there, right? Payment success. Okay, payment success. Now, this guy is also listening to the same topic. Okay, so now he say, wow, payment success, now I need to react, and he go and activate the connection. Right, activate the connection. Now, he published the message saying activate success. Okay, this is a payment success. This is an approval success. Okay. So now he said payment success, sorry, activation success. Now this listening to the same message again. Now they can use an email service or notification service or SMS service or whatever you have. Let's say here notification, right, or email or whatever. Then this service will take this. This service will send the email, right? See, it worked, right? So now we have a complete solution. No one is waiting, no thread is waiting, nothing, everything running smoothly. Okay, everything running smoothly. Why? Because completely we are depending on the messaging platform. Of course, if the messaging platform down, entire system down. But if you use something like MSK or any Kafka based cluster, you have a multiple replicas. It's not like it's highly available cluster, right? No need to worry about that much on that. And you can have it's a cluster. You can guarantee the high availability of the cluster, right? So let's say now this service is not available. Okay, it's fine, right? You can go here and then this waiting for this one, right? No one is thread are waiting, but it's just a matter of time. He come and it come the response, and then rest of the scene will continue. It's like a state machine, right? It's not a state machine, but it's like, so you go to some state, waiting until that complete. When that complete, you move to the next one, right? It's complete solution. But there are some missing pieces here. Okay, so one is it's good to have a monitoring solution. Monitoring. Okay, why monitoring service is required? Because in that case, if some service is down, if one of these services down, you can get an alert. Or not you or admin or someone who's maintained this cluster can get the alert, right? So also you have a logging services and security. I just forget the security for this solution because I don't want to make it overcomplicated. So security has to play a major role here, right? Because each of these messages ideally should be encrypted, because encrypted in the rest and encrypted in the transition both. Okay, so it's a good way to do, because you are transferring the NIC numbers or the passport numbers. NIC numbers is also Sri Lanka. The passport number, what we discussed in the previous video. So passport number you're transferring here and there, right? So therefore encryption has to be incorporated with this one. This is a good solution, right? Let me see. This solution looks like almost complete, but some of you may have a questions like this. So this new connection request is coming from a UI, and then how UI knows what's happening? UI knows waiting, right? Because it's published the messages, no one is waiting. How UI knows what's happened? That's why we use this notification, right? So this notification, this is a whole new topic for a different video, because I'm going to explain you a design to handle a push notification for a backend, for a front end from the backend on this type of event-driven solution, right? How UI keep update what's happening without pulling always the status, right? And that's why this notification channel is here. You can easily use a WebSocket or socket-based channels to get the notification from the backend. And also there is a possibility when they submit, right, this guy can issue something like a unique ID to this request, right? And then you can have a separate service where that service can, if like sometime user wants to see what's happening to my connection, and then user can see, send this tag to this service and asking, hey, what's happened there? Then he can see the state, because it's like a state machine, right? One after the other. Okay, verification success pending payment, something like that. You can solve it that way, but I'm not going to explain that because it's a different topic, a whole new video, and I'm going to explain that with how to handle the notification using a socket, WebSocket. Okay, so let's see the orchestration model, how we can do the same solution with the orchestration model. Okay, so let's see how we can do the same solution with the orchestration model. In the orchestration model, it's the same thing. We have this new connection service. Okay, so this is new connection service. Okay, naming convention a little odd, new connection service, but just think it's a connection service. Okay, so now what this do is we have a separate command service. This is a unique service in this SAGA implementation, because this is not the choreography, this is the command model. This is the command service, right? So what the command service do is, when the new connection comes, this tell to the command service, hey, I got a new connection request, right? Now command service talk to our fixed line service and the fixed line service, hey, can you verify this passport number, right? When the fixed line service done, it tell, hey, I verified this. Now it can tell this, what was that? TV, right? TV connection, TV service, can you verify this? It says, I'm verified, right? So, but keep in mind, these things can do parallel, right? Both of these. This is not supposed to have like this, but you just think like that, okay? So now, when that happened, command talk to finance service, hey, finance service, can you make the bill, right? Oh, it should be a black color, right? Finance service, hey, color convention, okay? So let's have a black color, right? Finance service, hey, go ahead and deduct the payment. And then when the finance service done, it tell next service is our activation service, or what did we call? Operation service, right? Operation service. So to activate. When the operation service activate, it tells here back, hey, it's ready, and then you can send the email. So see, everything is governed by centralized command service, right? People implementing this in a little different ways. So when this command is go here, it can talk to this, or sometimes people say, yeah, if the finance is done, finance, no, next one is operation, but that's a bad idea, because then your governing rules is going across the services, which is again, we go back to the same HTTP problem, right? But this case, it is not event driven, but you can have a hybrid one. You can have this one as an event driven, right? For example, what you can do is when the new connection comes, right, and then the command is publish the message to the message broker with a particular target service, right? Not necessarily be HTTP. This can publish to a, let's say, a Kafka, right? Let's say Kafka, okay? So now you can publish the message saying, hey, target, or even pattern or something like that. Target is verification services, right? Then verification service will listen to that and get that, okay? And then verification service respond back to the command service. The command service is saying, hey, other event to this one, now target is finance, like that, right? You can have a hybrid. This is an idea. Whether you implement with the HTTP or whether it's implementing with the messaging, it's up to you, right? But, so why we have two different ways? Because with the choreography implementation, the biggest disadvantage is if you have a bunch of events, if you have multiple hundreds of events, then you may create a deadlock situation. Okay, not the deadlock situation. Okay, that's how it works, right? Let's say you have your service, right, here, and then it published to the message, right, and this message is listening by this service, right, okay, and to complete this message, let's say this is a B service, right, and then same message get to the C service, okay. To complete this transaction, C need to wait for the B and B need to wait for the C. In some situation like that, then you are creating a deadlock, like your event getting locked. So it will be really hard to solve this type of thing, and also it's really hard. It might be hard to do the integration testing when you have hundreds of thousands of events, right? So therefore, that will be a bad pattern. I mean, it's not a bad idea to implement that, but as long as you can carefully manage it, okay? So, but in that case, having a centralized command module will help you, because if something is changed, let's say for example, in our case, we activate first and go to the billing, you just need to change the command service, okay? You don't have to change anything, you just do the command service, because command service is the one decide after this step where to go, right? So therefore, if you have thousands of this type of call to coordinate, might be an advantage to use the command service. Again, the disadvantage for the command using the command service is the same, because If some change happen, you need to redeploy the command service, because command service is kind of a centralized hub for all the knowledge. Okay. So there is no one solution to fit all, but you need to make it case by case based on your system, based on your solution. You always need to see where the solution can go, and then will this come and bite me back. So you need to think like that, and then you can come up with what is the best pattern for your project, right? So that's being said, this is again like a whiteboard solution, right? We need to see really implement this. So in the next video, I will, I cannot guarantee it's the next video because I'm going to record another video in a while, but because I need some time to build this. I probably need to wait till the weekend to build this solution, the next weekend. So then I will build this and I will publish the real implemented solution to demonstrate this one. Okay, till that, enjoy the other videos which coming in the next few days, and stay safe and take care.